Hello everyone and welcome to all of you to our channel Schrodinger's Cat. This is basically the Devabrata here. So in our previous lecture we had discussed the electrostatic induction and the alternating current from class 12, and your today's class will cover the rotational motion, and here the rigid body, center of mass and its motion, torque and equilibrium of rigid body, moment of inertia, kinetics of rotational motion and angular velocity, angular momentum and its conservation, dynamics of rotational motion, and total number of questions are coming in the NEET exam. There are 3 or 4 questions, and JEE Main 4 or 5, and the advanced 4 type of questions are coming specially in this topic. So basically it is an important and hot topic. So let's get started. First of all, I just confess one thing. For your exam point of view, today we will just summarize this chapter in a nutshell. Basically, this is the problem solving class. Summarize the chapter, and after we have got time, we would do theory elaborately. This is basically the exam point of view. So first of all, in the rotational motion, that the rotational motion of a rigid body, that moment of force or basically a torque, the torque is defined as, suppose this is a rigid body and force acting in the directions F, and this is the O, so this distance is R. So we just write tau is equal to the R cross F. Tau is equal to R cross F, basically the R F sin theta, and the angular acceleration alpha be the del omega divided by del t, and relation between the linear and the angular acceleration, that the alpha angular acceleration is linear acceleration divided by r, or a equal to alpha r. Relation between the torque and the angular acceleration, that tau equal to I alpha. This is relation between torque and angular acceleration. Next one, that moment of inertia. So suppose this is a rigid body, center of mass, this is point M1, M2, M3. This is the R1, R2, R3. So we have tried that the I is equal to M1 R1 square plus M2 R2 square plus ... This is written as the sum mr square. Next, the radius of gyration, or you just pronounce here the gyration, that moment of inertia I equal to mk square, where the radius of gyration is k root over of I by m. This is called the radius of gyration. Now next one, the equation of rotational motion. So for rotational motion, that omega equal to omega naught plus alpha t, theta is equal to omega naught t plus, this is the equation of motion, half alpha t square, and next one, that the omega square is equal to omega naught square plus 2 alpha theta. Next one, the kinetic energy of a rotating body, that the kinetic energy k half I omega square. This is for the rotating body, and I be the moment of inertia about the axis of rotation. Next, kinetic energy of a body in combined rotation and translation, that the kinetic energy I half I center of mass I omega square plus half m v naught square. In this case of pure rolling, the v naught will be the r omega. So kinetic energy would be that kinetic energy is in the form half ICM square plus mr square omega square. Next, the angular momentum L is written I omega, and the relationship between the torque and the angular momentum, the time derivative of L dl dt is equal to tau. Angular momentum of a rigid body combined translation and both rotation, that is written L, the LCM plus m r naught v. This formula is very important for NEET, and I think in IIT JAM exam this formula type of questions are coming on time. L equal to LCM plus m r naught cross v. Next, the angular pulse is basically change in angular momentum, that is written the del L is equal to L2 minus L1 tau dt. If external torque, if the external torque is 0, then dl dt is equal to 0, or dl equal to 0, that L equal to constant. Next one, work done by torque in rotation theta 1 to theta 2. Theta 1 to theta 2 rotation, the work done would be W theta 1 to theta 2 tau the theta. Power delivered by torque means P dk dt. Here K means the kinetic energy. So ddt of, just put this value half I omega square, that would become tau omega. This is the power. Next one, the moment of inertia of two theorem. One is parallel and another is the perpendicular axis theorem. So first one, the parallel axis theorem. I just draw a line for your better clarifications. That parallel axis theorem, that suppose this is a rigid body and here with a distance, suppose this is the M point of mass and this is the R, the distance is the D. So here the parallel axis theorem states that I equal to I center of mass plus md square. Now the perpendicular axis theorem. This states that this is a rigid body and this is axis origin x, y, z. We just do in the clockwise. So this is a R point, this is R, and x, this is y. So z component of moment of inertia is equal to ix plus iy. Now moment of inertia sum regular shape of body. Moment of inertia of some regular shape of body. So first of one, thin rod. This is the thin rod. Moment of inertia along this, and this is the L. For thin rod, I would be the m L square by 12. Here also, this is this position, suppose A. In this point B, IB is equal to m L square by 3. This, you just apply here the parallel axis theorem. The center of mass ml square by 12 plus this portion is basically the L by 2. Next one, the rectangular plate. The rectangular plate, this type of shape, and this is the L and the B. You have to find the moment of inertia in this rotation about axis perpendicular to the plane of plate and passing through the center of mass. This is very important term that I just write here, about the axis perpendicular to plane, perpendicular to the plane of plate and passing through its center of mass, passing through of its center of mass. So this would become I equal to m L square plus B square by 12. Next one, for the ring, this is a ring of radius r, so I would be m r square. Circular dish of radius r, you have to find this moment of inertia, that half m r square. Solid cylinder, that the solid cylinder center of mass in this I equal to half m r square. This is for the solid. And the hollow cylinder, means each portion is cavity, this type of. So for hollow cylinder, that the inner radius is r1 and the outer radius, that be the r2. So this is for the hollow case. So I would become that the half m r1 square plus r2 square. Next one, solid cylindrical rod. So for the solid cylindrical rod, that this is the r and the L length, the I would become m L square by 12 plus r square by 4. For solid sphere of radius r, moment of inertia along this direction 2 by 5 m r square. For spherical shell of radius r, that 2/3 m r square. Last one, the hollow sphere. This is hollow sphere where inner radius the r1 and the outer radius is r2. You have to find moment of inertia in this direction, that 2 by 5 m, that r2 to the power 5 minus r1 to the power 5 divided by r2 cube minus r1 cube. R1 and R2, the inner and the outer radius. Last one, that here we just now compare the linear and the rotational motion. This is the translational and the rotational. We just compare for your better understanding. So first of all, here the displacement is s, here angular displacement is theta, velocity is v, here omega, here the acceleration a, here alpha. For your better concept, inertial mass, this is called the inertial mass m, and here this would be called the I, moment of inertia, the force F, here the torque tau, momentum mv, here I omega, the power means F dot v, here the tau omega. This is the rotational power. Kinetic energy half mv square, and here half I omega square. So next one, the linear impulse that the F dt is written as the P final minus P initial. Here this is the tau dt, that would become the L final minus L initial. I just write here one thing. This is the displacement, velocity, acceleration. This is the inertial mass, force, and this is the momentum. And here the power, here the kinetic energy, here the impulse. So go ahead our next topic, that the combination of translation and rotational motion. I just draw a line for your better clarification. The combination of translational and rotational motion, that first of one, that translational plus rotation, that is equal to combined translational and rotational. The equation of motion written here, that the x equal to x naught plus uxt plus half axt square. Basically the ux is equal to ux plus axt sum over fx is m into a cmx sum over f component of y component of f, that a cm y, and the tau cm is equal to I cm alpha, omega naught plus alpha t, and the theta omega naught t plus half alpha t square. Angular momentum in case of combined translational and the rotational, that would be LCM plus m r naught cross v. This is written as the ICM omega plus minus m v naught r perpendicular. Next one, that the kinetic energy, just a minute. Kinetic energy in combined translation and rotation, that the kinetic energy half m v square plus half I omega square. Rolling of solid sphere. Next one, that velocity and acceleration diagram of body in rolling. I think this would be helping you for your JEE type of questions. First is the V diagram, the velocity and the acceleration diagram. Suppose this is a rolling body, and here the point A, B, C, D. For A point, this is the V naught. So here omega r. I just write here. So in A point, that VA is equal to V naught plus omega r. In point B, here this is the V naught, this is the omega r, and this resultant would be the VB. So VB would become that v naught square plus omega r whole square. Next, in C point, here this is v naught, this is omega r, so Vc would become that v naught minus omega r, and in the point D, Vd, as usual of Vb, that v naught square plus omega r whole square. This is the V diagram. And next one, the A diagram. So for A diagram, this is also a rolling body of 4 point A, B, C, D. We just find the acceleration between this point. This is the A naught, and here A naught. This is the alpha. You have to find this point A, B. Here also this is alpha. This is the A naught. In D point, the alpha. This is here A naught. You have to find A, D. So first of all, at the A point, that A naught plus alpha. In B point, AB, that root over A naught square plus alpha whole square. In the C point, AC, that A naught minus alpha r. This is the equation of motion of the alpha, and here the equation of motion of omega. Next one, the D point, the AD would become root over H, the B point, A naught square plus alpha r whole square. So this is for pure rolling, that V naught equal to omega r, and here the pure rolling A naught equal to alpha r. Next one, very important, that rolling in inclined plane. Rolling in inclined plane. This is a plane rolling a body. This body. Here this is time t, velocity u0, mass m, I, moment of inertia. This is the height h, angle is theta. So sufficient rough, and here this is body is coming with angular velocity omega. This is linear velocity v and the omega. So here during rolling motion, and this be the v bottom. During rolling motion, the acceleration of center of mass, that the mg sin theta divided by m plus I by r square. This is important, and the alpha would become a center of mass by r, and the bottom velocity would become 2 mgh divided by m plus I by r square, and the omega would become v by r. So I just compare one thing, that the rolling motion for solid sphere, the I, here the ACM, and here the B bottom, that for solid sphere 2 by 5, this would moment of inertia, that 2 by 5 f r square, and this would be the 5 by 7 g sin theta, and here root 10 by 7 gh. Next one, for hollow sphere. For hollow sphere, I would become 2 by 3 m r square. You just know, put this value in this equation, you just got the ACM 3 by 5 g sin theta. You just do not keep in mind this, after calculation this would become. So for solid cylinder, that it would become the half m r square, and here 2 by 3 g sin theta, so here 4 by 3 gh. This is the comparison of last one, that hollow cylinder. For hollow cylinder, m r square half g sin theta, and this is the root over gh. So we just cover here the chapter summary in a nutshell. We just now switched to a lecture in that the problem discussion session. First problem in coming NEET 2020, it's saying that three identical sphere of each mass m placed at the corner of a right angle during the mutually perpendicular side of two semi. You have to find the center of mass point, center of mass vector. So just join this point. So here OA given that the OA 2I and the OB direction is 2J. So the RCM would become that M1 R1 plus M2 R2 plus M3 R3 by M1 plus M2 plus M3. Just put this value. M R1 means OA, this is R2 means OB, and R3 means O point. Suppose this is the O, A and the B. Divide by total mass M, M and the M. Just put this value. So M 2I plus M 2J divided by 3M. So it would become 2/3 I plus J. So C would be our correct answer. 2/3 I plus J. Next problem is from the NEET 2016. From a dish of radius r and mass m, circle hole of diameter r, whose ring passes through the center of cut. What is the moment of inertia of the remainder? So you have given a dish and cut in a small section. This is the dish of radius r, cut in this portion of radius r by 2. So you have to find the I remainder part. Remainder part means this type. This is the I center of mass you have to find. So that for solving this, that I would become the I remain plus I of radius r by 2. So I remain would become center of mass along this point by center of mass of radius r by 2. Just I means m r square by 2. Just put this value minus. This would become I r by 2 means the m by 4 mass r by 2 whole square by 2. Here this would written as mass m by 4, r means r by 2 whole square by 2 plus m by 4 r by 2 whole square. So it would become that the mr square by 2 minus mr square by 32 plus mr square by 16. So after simplification you would get 13 by 32 mr square. So I think 13 mr square by 32, A would be our correct answer. Now go ahead our next JEE Main 2018. 7 identical circular planar dish, each of mass m and radius r. You have to find the moment of inertia of the arrangement, moment of inertia of the whole arrangement. So by the theorem of parallel axis, by the parallel axis theorem, that you just know I equal to I naught plus mr square 7. So 7m, r means 3r. So R, here R, here R, here R. So just put this value. So this would be mr square by 2 plus 6 m r square by 2 plus, you just use parallel axis, so m into d square, this means 2r square plus 7m cr square, this one. So just calculate, here would be 181 by 2 mr square. So I think A would be our correct answer, 181 by 2 mr square. So next one, that the JEE Advanced 2022, a flat surface of a thin uniform disk of A of radius r is glued to a horizontal table. Another thin uniform disk B of mass m with the same radius r rolls without slipping on the circumference of A as shown in the figure. A flat surface of B also lies on the plane of table. Center of mass of B has fixed angular speed omega of the center A. You have to find the angular momentum of B is n m omega r square. The angular momentum of B, basically the LB angular momentum, is given n m omega r square. You have to find the value of n. You have to find the value of m. So here, suppose this is a joint, and here the omega, and here is the omega naught, and here the velocity is v. This is for A and the B. So first of all, you just know that v equal to omega r. R means 2r, here r and the here r, and the v equal to omega naught r. This is for the no slipping case. No slipping, that v naught equal to, so we just get here from these two that omega equal to 2 omega. Omega naught equal to 2 omega. So you have to now find the angular momentum L, that I just do in a chapter summary class, that here the translational as usual as the rotational. So m r vc plus I omega, ic omega c, that is omega c means omega naught. Just put this value. So m r 2v plus half m r square omega naught square. So it would become that 4 mr square omega. Just put this value, 4 mr square omega plus half m r square omega naught means 2 omega. So it would become the 5 m r square omega. This is given that n m omega square r. So n would be 5. 5 would be our answer, B. Last one, recent questions coming in NEET 2024, that a bob is wheeled in a horizontal plane by means of a string with a initial speed of omega rpm. The tension ht, speed becomes 2 omega. So what would be the tension become? So you have to find the t dash. T would given, you have to find the t dash. So here apply that Fe equal to mv square by r. So it would become the m omega square r. So T means m omega square r, and the T dash, that given 2 omega, omega to 2 omega, T to what? T dash. You have to find the T dash. So T dash means m omega means 2 omega whole square r. So T dash by T would become, T dash means m 4 omega square r by m omega square r. So it would become 4. So T dash is equal to 40. 40 would be our correct answer. Answer would be B. So we just cover here that 5 important question coming from the NEET, JEE Main and Advanced, and I think after solving these 5 questions you just do solve you yourself all type of questions from the rotational motion. For your better concept, practice and understanding, I usually give 5 another questions for your homework. You just do in your home and mail with this ID. You just pause the video and take a screenshot. So last one, that our contact that solve this homework, and if anyone needs this file of my YouTube lecture, just mail without no hesitation with this ID cat Sodinger 1935@gmail.com. So last but not the least, thank you everyone, and stay well and happy. Goodbye.